All right, it was 8, day 2. We're still doing powers of complex numbers in trig form. We're just going to do a bunch of them is really what's going on. What's going on today? I got z over here. I'm going to convert it, and then from -1 up to the 8th power, we're just going to do a whole bunch. And this one slide is our lesson for 8, day 2. Okay, so really nothing new. It says to like show them on the argon diagram. That's like converting them back to a plus bi. That would take more space than I have here. I'll draw you a little sketch and kind of show you, an interesting little thing about kind of what these, if we were to graph all these numbers, what they would do. And it looks kind of cool, and I'll show that. But I'm not going to go through the process of graphing them individually because, we'd have to convert all of them back to rectangular, which I'm not going to do, okay? It would just be a little bit too much space. All right, first thing I got to do is, this is in part A, I got to get my number converted, right? Here it is, 1 minus I, right? This one I will, this one I'll graph just because I can. But that would be like right here. 1 to the right, 1 down. All right, first thing would be to get R. A is 1, B is -1. R would be 2. Okay. Double check that work and make sure you're good there. Then we get R square root 2. And of course, we got to do a tan inverse to get theta. Take tangent inverse of -1. If you did it off your calculator, it's going to tell you -45 degrees, which I don't love. I mean, I kind of do. It puts us in quadrant 4, which you can see down in the graph. That's where we are. But I do want it as a positive, so I'll add 360 and get 315. Okay? This is actually one of our answers already. Z to the first, right? I essentially have, because I've seen here that Z is square root 2 CIS 315. Okay? Now we'll kind of go off to the races and just do a whole bunch of powers, right? Again and again, just practicing the rule here. That R gets raised to that power and theta gets multiplied by that number. Okay, so to the negative first, I would do square root 2 to the negative first power, CIS -1 times 315. Haven't seen one of those before, but I do want you to see that it's just the same thing. Whoops. So I get 1 over square root 2 when I apply the negative first power. Oops, there should be a negative. That gets multiplied by -1. Okay. What I would do then here is, let's see here, rationalize that. And then here I'd have to add 360. And I would end up with that. Square root 2 over 2 CIS 45. That would be to the negative first power. Okay, same rule as always. R to that power, multiply theta by the given number, right? In that case, it was -1. Here it's 0. Anything to the 0 power is 1. 315 times 0 would be 0. There you go. 1 CIS, 0. Keep in mind, z to the first, right up there. Already have it. That was the original complex number itself. So here I'll just skip up. Do z squared. R will be 2. Let's see here. This would be what, 6? 630, I believe. Now we're not going to leave it like that. We'll subtract 360. And get it back to 270, right? Because our angle that we give should be between 0 and 360. Needs to be between 0 and 360 for our final answer. All right, keep cruising here. Square root 2 to the 3rd power. R would come out to be the square root of 8. Three times 315 would be 945. And that answer's getting close. 8 could be written 2 square root 2, and then you'll see this happen a bunch on the others because I'm getting, as I'm multiplying by n, I'm getting way bigger than 360. So I take 945, and then I'm just going to subtract 360 until I get back, until I get back to an answer that I'm looking for. I got to subtract it twice. And you'll get 225. Okay. Square root 2 to the 4th. CIS 4 times 315. Square root 16. CIS 1260, right? Square root of 16 is 4. And then again, we play this game with 1260. Start taking away 360. Once, twice. Here you have to do it 3 times to get back to 180, okay? I'm going to draw out the work for one more. I'll do z to the 5th, right? I'm kind of running out of room. And then what I'll do is I'll leave the answers, right? And we'll see the last 3, z to the 6th, z to the 7th, z to the 8th. You should try those, right? To make sure that you're good to do a few on your own without me showing you the work, right? Because you'll have the first 5. And again, I'll leave you the answers for the last 3. Square root 2 to the 5th, CIS 5 times 315, right? And then each of these, my next step is I just apply that, right? 2 to the 5th power is 32, but that's still all underneath the square root. And then when I do 5 times 315, I know I'm going to get just a really, really large angle, way too big to give as my final answer. Okay? Four square root 2. for R, right? Because you could split up 32, 16, and 2. Square root of 16 is 4. Well, with 1575, keep taking away 360, and you would get that back to 135. Okay? And again, these last three will just be answers that you can confirm on your own. Z to the 6th, you should get 8 CIS 90. Z to the 7th is 8 square root 2. $45. And Z to the 8th, the final one it said to do, 16 CIS 0. Okay, no work for those, but see if you could, same. It's done the same way, right? You're using n equals 6, n equals 7, n equals 8, right? A little bit of simplifying to do to get back to your simplified answer for R and your final answer for theta, okay? I'll draw in a few of these, right? On the graph kind of does an interesting little thing, okay? I'm not expecting you to graph all these because you would have to convert them all to back to rectangular form. But I just want to kind of show you, if you were to graph all these powers, they do kind of a cool thing. I kind of go over some of my work there, which is okay. So -1 was down here, and here's what happens on the graph as we take these powers. We went to here, to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th. Kind of makes like a spirally, almost looks like half a seashell kind of thing, but that's what's happening graphically as we keep upping the power higher and higher. But yeah, that's a bunch for one slide. That's loaded with information. Keeping in mind, all we're doing is really the same thing again and again, which has been the theme of Learning Target 8.8. Take a number, complex number in trig form, and can you raise it to a power, right? That's all you're seeing on the slide, with tons of examples.